Earlier in this course, I gave you an introduction to a few fundamental concepts in electronics, such as Ohm's law and Kirchhoff's laws. Now it's time to add a few more concepts to the list. Understanding the behavior of electronic circuits begins with three fundamental concepts: voltage, current, and resistance. Let's break these into simple terms. Voltage, often referred to as electrical potential difference, is the driving force that pushes electric charge through a circuit. You can think of it much like pressure pushing water through a pipe. It's measured in volts and symbolized by the letter V. Next, current. Current is the flow of electric charge in a circuit. It's the actual movement of electrons through the conductors. Very much like the movement of water molecules that flow through a pipe. Current is measured in amperes or amps and represented by the letter A. Next up, resistance. Resistance is the opposition to current flow within a material. Materials in a circuit can hinder the flow of electrons to varying degrees, and this is the resistance of the material. It's akin to friction that slows down the water flow. Resistance is measured in ohms and denoted by the Greek letter omega. These three are interrelated in a way that is defined by Ohm's law, which states that the current flowing through a conductor between 2 points is directly proportional to the voltage across the 2 points and inversely proportional to the resistance. This relationship is neatly summarized by the formula I equals V divided by R. Think of a basic electronic circuit as a loop. The voltage source, such as a battery, provides the necessary energy. Electrical components, which could be anything from a light bulb to a resistor, regulate the current flow and control the output of the circuit. The resistance determines how freely current can flow, ultimately affecting the function of the device.